Hi everyone, welcome to the next part of the series. As you may know, the questions pattern of the CKA exam has changed. In this video, we will explore an interesting question related to network policies. The question is, you have a front-end and back-end deployment running in their respective namespaces. These two deployments need to be communicate with each other. Your task is to apply an appropriate network policy from the provided directory. Please note, do not delete or modify the existing deny all network policies. This means you will have some deployments already running in the cluster and you will be given a set of network policies. Your task is to choose the most suitable one that follows the principle of least privilege. Alright, without further delay, let's go to the cluster. Before we begin, I am recommending visiting our repository to check out all YAML files related to the scenario. You can easily recreate the scenario on your end using these files. First, we need to set the scenario. Let's check the namespace. I have already created a frontend as well as backend namespaces. Now let's run all deny policies. These all files you can find in our repository. Let's apply it. Okay, now we have applied deny ingress and egress policies to frontend as well as backend namespaces. Okay, next we need to deploy frontend and backend applications. Now we have deployed both applications. Let's check what they are. As you see backend in a MySQL deployment and it has a service also. So in order to access this port from other ports need to be called FQDN of that service, which means MySQL service backend.svc.cluster.local on port 3306. Next we need to check the front-end YAML files. This is a custom image built by myself. That container will try to connect FQDN, which means MySQL service.backend.svc.cluster.local on port 3306. If the connection is getting, then it will show a success message. Otherwise, it will restart. Okay, I have made this image and pushed it into my repository. You can access that image. It is publicly available. Okay, now our environment is ready. Next, we need to answer these questions. As per the question, we can find some network policies under /netpol folder. And we need to choose the most suitable one for allowing connection between front-end port to backend port. Okay, let's check the port status now. Okay, now we can see backend port is running and the front-end port is in error. Let's check the logs first. Clearly we can see the front-end port is unable to connect to the backend port. Why it is blocking? Because ingress and egress deny policies are there that will block the traffic. So next we need to find the best policy for allowing the traffic between front-end and backend ports. So let's find the YAML files. Please note, in the exam you will find similar questions. So you have to practice it very well. Okay, we can see 3 YAML files are there. Let's check one by one. The first YAML file will allow the connection from the namespace frontend to the backend namespace on port 3306. But we can't say it is the least privilege because it will allow any ports from the front-end port to the backend. So it will work but not suitable for the scenario. Let's check the next one. Next one is not allowing any connections. So we can avoid this YAML file. Let's check the last one. Okay, this is the best among the three. The policy is applied to the backend namespace and allowing connection from the front-end port in the front-end namespace to the backend ports on port 3306. This is the least privilege YAML file. Before applying it, make sure to double check the labels on both ports and the policy. We can see that port label is app equal to frontend. Now let's check the namespace label. It is kubernetes.io/metadata.name is equal to frontend. In the YAML file, the same labels are correctly mentioned under match labels. So let's go ahead and apply it. Now the policy has been applied. Next, we need to recreate the port. Okay, the port is still unable to connect to the MySQL port. Why? Because the network policy is applied only to the backend namespace. However, the front-end namespace has both deny ingress and deny egress policies in place, which puts it in an isolated state. To allow the connection, we have two options. Either delete the egress deny policy from the front-end namespace or apply an egress allow policy targeting the backend. Okay, but in the question they are mentioned to do not delete any deny policies. So we need to create an egress allow policy in front end. To do that, we can refer to the documentation for guidance. Go to the documentation and search for network policies. Take the first one and find a egress policy. Okay, we can take this as a reference. Namespace should be front end. Match label should be app equal to front end. Okay, perfect now. Our egress policy is ready for apply. It's still not working as expected. One possible issue could be the presence of deny-all egress policy in the namespace, which block all outgoing traffic, including DNS resolution. As a result, internal service name like the FQDN, that means which means my service default.svc cluster.local will fail to resolve. In our case, we need to explicitly allow egress access to the cube system namespace on port 53 to enable DNS queries. Reapply the YAML files. It should work. Yes, our pod is now running. Let's check the logs. Yes, it is connected to our backend pod. Please note, in this deployment, we are using a custom image which I created for simulating the scenario. In the exam, most likely containers will not restart even if the connectivity is lost. So you don't need to delete the ports after applying any network policies. Instead, you should get into the ports and use netcat command, nc command, or curl command to check the connectivity. Don't worry, I will show you that. This is a command you have to use in the exam for testing connectivity. NC means netcat. Netcat minus SV service, uh, FQDN, and the port. Okay, this is the end of the network policy question. Please practice. This is a sure short question. Let's move to the next question. The next question is comparatively small task. Confirm that the cert manager application and its components are running in the cluster. Create a list of all cert manager related custom resource definitions and save the list to the file. It should be a resources.yaml file under slash. Use kubectl in its default output format. Using kubectl, extract the OpenAI documentation for the subject field inside the certificate custom resources. Save the output to subject.yaml file under slash. Okay, let's move to the cluster. Let's check the CRDs first. Okay, next we need to find the cert manager CRD. Okay, we can see 6 cert manager CRDs are there. We need to take this as a output and paste into a file. Okay, first task has been completed. Next, we need to extract the documentation for the subject field inside the cert custom resources and save the output to a subject.yaml file. So we have to use explain command. Let's copy to subject.yaml file. Let's verify it. Okay, done. We have successfully completed this task. Okay, this is the end of this video. We will come with few more scenarios. Stay tuned. Bye.